Hello viewers, welcome to this video. Right, in this video let's see how to deploy Spinnaker in a Kubernetes cluster. So many viewers ask me how to deploy Spinnaker in a Kubernetes environment. So that's what we're going to be seeing in this video, and probably in next few videos we will see, if I've got some time, I'll also show you how to use Spinnaker for your CI/CD environment. So Spinnaker is a continuous delivery and continuous deployment platform. You can use Spinnaker to deploy resources, deploy your application to Kubernetes, to multiple clouds like Azure, AWS, GCP. And in this video, let's see how to deploy Spinnaker in a Kubernetes environment. And probably in the next few videos, I will show you a continuous deployment example to show how to deploy your apps to Kubernetes using Spinnaker. Alright, so I'm going to head to the Spinnaker architecture now. Spinnaker architecture, just to show you what are all the components involved in Spinnaker. So Spinnaker consists of several microservices like Deck, Gate, Arca, Cloud Driver, Front 50, Roscoe, and few others. So down below, so this is the Spinnaker architecture. So the components involved in Spinnaker. Deck is the web UI. So when you go to Spinnaker web dashboard, so that's the web UI part of it. And Gate is the API gateway, like the Kubernetes API server. So all the interactions from the Deck, from the web UI, all the operations you do will have to go through this the Gate API. And there are other servers. So there's this Cloud Driver that takes care of the abstraction. So whenever you deploy your resources to any cloud, the Cloud Driver component will take care of the actual deployment and so on. And Halyard, so we will be using Halyard to deploy and manage Spinnaker. So you can deploy Spinnaker in your Kubernetes application using a Helm chart. You can do Helm install Spinnaker. But the recommended way, the best practice, is to use Halyard to deploy and manage Spinnaker. So when it comes to upgrading your Spinnaker, if you're using Halyard, so it will be a lot easier to upgrade your Spinnaker with zero downtime. So the recommended approach is to use Halyard. And down below you've also got some port mappings, what are all the services and what ports they use. The only two things that we are interested in is the Deck, the web UI, which runs on port 9000, and the Gate API server, which runs on port 8084. Alright, so how to install Spinnaker in your Kubernetes cluster. So let's look at the documentation. Install Spinnaker. There are a few steps to install Spinnaker. So these are the basic steps. So in this video, we'll be covering the first 5 steps here up to the deploy Spinnaker. So install Halyard. Choose your cloud provider, choose an environment, choose a storage service, and deploy Spinnaker. So the first 5 process we'll be following in this video. All right. So there are different pages that you need to navigate to install Spinnaker. You have to basically follow these processes. But I've also got my own documentation. So I've followed this many times. I've trial run. I've tested this Spinnaker deployment many times, and I've got my own documentation on how to do that. So let's go to my GitHub Kubernetes repository, github.com, just me an open source. And if I go to Kubernetes, and inside the docs directory, set up Spinnaker. Alright, so that's this documentation which we'll be following in this video. But at a high level, I'm going to explain what it takes to install Spinnaker in your Kubernetes cluster. So the first thing is install Halyard. And if I open that, you can either install Halyard directly on your machine, or you can use a Docker container. But if you want to install it on a machine, the only supported operating system are Debian, Ubuntu, or Mac OS. So you can see here, you grab the installation script, and if you read through the installation script, it applies for the Debian or Ubuntu based distribution. But I'm running Manjaro, which is Arch based, which is not supported by this method. So I'll be looking at the Docker option. So running Halyard as a Docker container, and you can run Docker container in any platform, cross-platform. So I will pick up that option. So that's the Halyard. The first important step is to install Halyard. Next is to choose a cloud provider. So where do you want to where do you want Spinnaker to deploy your applications to, whether it's Kubernetes or AWS or Azure, GCP or OpenShift or anything. So you'll be choosing the cloud provider, and then you will choose an environment, which means in which environment you will be deploying the Spinnaker application itself. So we'll be using Kubernetes environment to deploy our Spinnaker, and then choose a storage service. So that's very important. So Spinnaker, when it deploys application to your Kubernetes or any cloud provider, it needs a persistent storage, so to store the information about the applications that it has deployed. So we need to have an object-based storage like Amazon S3 or something. But since I'm using bare metal, I can use S3, but I'm going to go for the Minio. So Minio is an object storage for cloud environment. So you can run Minio as a Docker container, and you can run Minio in your Kubernetes cluster, which I will show you when we go through the process. And then finally, we will be deploying Spinnaker. All right. So that's the theory part of it. So now let's head to the actual hands-on. So the joy of installing Spinnaker in Kubernetes cluster. I really enjoyed deploying Spinnaker. Lots of moving parts, lots of steps to follow. But if you follow these steps carefully, you will be able to run Spinnaker in your Kubernetes cluster. So one thing to note is, I don't need this documentation anymore because I've got my own documentation here. But one thing to remember is Spinnaker involves a lot of microservices. So your cluster needs to have at least 4 cores and 8 gig of memory. All right. So my Kubernetes cluster, if I show you kubectl get node, so I'm running version 1.16 Kubernetes with 1 master node and 2 worker nodes. And the 2 worker nodes, each of them have 2 CPUs and 4 gig of memory. So in total, between the worker nodes, I've got 4 CPU and 8 gig of memory. So if you allocate anything less than that, when you deploy Spinnaker, all your microservices will be in the pending state. It will be waiting there for resources. So bear that in mind. You need to have at least 4 CPU and 8 gig of memory. Otherwise, Spinnaker, you won't be able to deploy Spinnaker. So if I show kubectl describe node kworker, and down here, if you see the capacity, CPU is 2, memory is 4 gig. So similarly, in kworker 2, the other worker node, I've got 2 CPU and 4 gig of memory. So in total, I've got 4 CPU and 8 gig of memory. All right, so I've also deployed MetalLB as the load balancer and dynamic NFS provisioning for dynamic volume provisioning. So those are the other 2 things that I've done. All right, let's follow. The first thing is to start your Halyard container. So for that, I'm going to create a directory, make directory under your home directory .hal, and we'll be binding this directory inside the Halyard. So when you stop and restart your Halyard container, there is this data that is persisted. Otherwise, if you don't do this, when you restart your Halyard, it won't have any of your configurations. All right. The next step is to run the actual docker run command. Docker run --name Halyard, and we are binding the .hal directory from our host machine inside the container under home Spinnaker. And the other thing is we are also mounting the kube configuration file. So under my home directory .kube directory, there is this config file. That's the kube config file. And I'm also mounting this under home spinnaker.kube/config inside the container. All right, so let's run that. And that's the Halyard container image. Docker logs -f Halyard. Yep. Let's give it a few seconds and it should be ready. And once it's ready, we need to log into this container. All right, so it should be ready in a few seconds. Yep, that's ready. Started main seconds, JVM is running. Okay, so now let's log into the Halyard container. Docker exec -it Halyard bash. Cool, we are inside the Halyard container. If I do which kubectl, it comes with kubectl installed, and we have mounted our kubeconfig file under .kube directory. So that is this config. So we should be able to connect to our Kubernetes cluster from inside this Halyard container. So if I do kubectl cluster info, yep, kubectl get nodes. Cool. So we can connect to our Kubernetes cluster from inside the Halyard container. That's something we need to verify before we proceed further. Okay, we've done that. kubectl cluster info. Okay, so now set Kubernetes as the cloud provider. So we want Spinnaker to use Kubernetes to deploy our apps. So that's what we are doing here. Hal config provider Kubernetes enable. So Hal config provider Kubernetes enable, we are enabling the Kubernetes provider. Right, Kubernetes provider is enabled, but no accounts have been configured. So Kubernetes is enabled. So Spinnaker needs to deploy applications to a Kubernetes cluster. So which Kubernetes cluster? So that's what we are going to do next. We are going to add a Kubernetes account. Hal config provider Kubernetes account add. Give it a name. Let's call it myk8s. The account name is myk8s. -- provider version is v2. -- context is, let's use the current context. kubectl config current context. Okay, so that's done, and we also need to enable the artifacts. Hal config features edit -- artifacts. Set that to true. All right, so choose where to install Spinnaker. This is the step where we choose the environment where we want to install Spinnaker. We want to install Spinnaker in a Kubernetes cluster. All right, so let's do that. Hal config deploy edit -- type is distributed -- account name is the account that we created, which is myk8s. That's done, and the next command is below commands needs to be run on your local machine where you have Helm binary installed. Okay, so we are inside the Halyard container. I'm going to go to my host machine now, and which Helm version -- short. I'm using Helm version 3. I've done videos on Helm version 3. If you've got Helm version 2, it should still work, but the commands might be slightly different. Now we are going to install Minio. Minio is the object storage. Spinnaker needs object storage to store the application data. All right. So now let's install the Minio in our Kubernetes cluster. So we'll be installing Minio in the same namespace as Spinnaker. So Spinnaker will be installed in the Spinnaker namespace. So we need to deploy Minio in the Spinnaker namespace. I don't know why it's like that, but I've tried deploying Minio in a different namespace, but that didn't actually work. So let's create a namespace. kubectl create namespace Spinnaker. And then now we are good to install Minio. Helm install Minio, and the command is here. -- namespace Spinnaker -set. We need to pass an access key and a secret key for the Minio, and then set persistence.enabled equals false. So if you don't have a dynamic volume provisioning, set this to false, but I do have dynamic volume provisioning enabled, so I'm not going to pass this option. But if you're just learning, if you just want to see how it actually works and you don't have a dynamic volume provisioning, you can set that option, which is -- set persistence.enabled equals false. But in production use cases, don't make that choice. Please enable persistence, because Minio, when the pod gets crashed or pod restarts, we need to have some form of persistence. All right, so let's deploy Minio in our Kubernetes cluster. So once that's done, Helm list -- all namespaces. Okay, that's Spinnaker. kubectl -n Spinnaker get all. Okay, so that's our Minio container that's running. It's not ready yet. Let's wait for it to become ready. Okay, let's check again. Yep. So our Minio container is running fine. We've deployed Minio, that's fine. And now there's one hack that we need to do back inside the Halyard container. So let's go back to the Halyard container and make this directory. Copy and paste it. And there's a file called front50-local.yaml, and we need to set the content of that file to be this one, spinnaker.s3.versioning:false. We need to disable S3 versioning because this is not actually S3. This is just Minio. Minio is like S3 based. It uses the same protocol, but it's not the actual AWS ES3. So we need to disable versioning. So for that, let's copy that command, copy that and paste it here. That's done. Now set the storage type to Minio. I'm gonna copy that, copy and paste it. So how config storage s3 edit, and the endpoint is http minio:9000. So since Spinnaker will be deployed inside the Kubernetes cluster, Spinnaker can talk to Minio using this URL, http://minio:9000. Minio is running on port 9000. Let's check. kubectl -n Spinnaker get service. Yep, Minio is running on port 9000. And the access key is my access key, secret access key is my secret key, the access key and the secret key which we passed when we deployed Minio. All right, so next command is, this is also required for Minio, whole config storage, copy that and paste it. And finally, we need to enable the ES3, whole config storage edit -type s3. Okay, cool. So that's done. And finally, we are going to choose which version of Spinnaker we are going to deploy. So for that, if you do whole version list, it's going to show you the list of available Spinnaker versions. So we have 1.15.6, 1.16.5, 1.17.2. Go with the latest version, 1.17.2. But I'm going to deploy 1.16.5 because I'm going to show you how to upgrade Spinnaker with zero downtime. So I'm going to choose 1.16.5, whole config version edit --version 1.16.5. Okay, so once that's done, we are good to go. That's it. We can deploy Spinnaker now. Whole deploy apply. That's all it's needed. Whole deploy apply. All right, so let's do this command. Watch kubectl -n Spinnaker get pods. So now you will see lots of different microservices getting deployed to the Spinnaker namespace. Basically, the different microservices that Spinnaker has will be deployed in this namespace, like Deck, Gate, Orca, Friend50, Roscoe, Eiger, Echo. There are lots of components, and in a short while you will see, yep, it's deploying all these, and you can see here Deck, Echo, Gate, Orca, Redis, Roscoe, and it's gonna take like 5 to 10 minutes. When I tested it, I think it took about 7 to 8 minutes. You need to wait for all the containers to become ready before going to the further steps. Okay, so what I'm going to do now is I'm going to pause the video and come back when all these containers are ready. It's going to take like 7 to 8 minutes. And then the next step is to edit the service. So how you are going to access the Spinnaker dashboard. For that, you need to edit the service, the Deck service and the Gate service, and change the type to node port or load balancer. And then we need a final whole configuration to make it available. All right. So let me pause the video here and come back when it's ready. Alright, so now we can see all the components have been installed and they're all in the ready state. So now what we're going to do is we need to edit the Deck and the Gate service, change the service type from cluster IP to node port. So if I do kubectl -n Spinnaker get service. So at the moment, the Spin Deck and Spin Gate are all cluster IP service. So if we want to access this from outside the cluster, we need to change the service type from cluster IP to either load balancer or node port. So if you haven't got a Metal LB load balancer installed on your cluster, you can go with node port. Let's edit the service. kubectl -n Spinnaker edit service spin deck. Let's edit the web UI service first, and then we will go to the Gate, which is the API service. So edit spin deck and change the type from cluster IP to node port, and under target node port let's change that to node port. Let's add node port and we want to make it a fixed port, so 32323 for example. Or if you want, you can use the load balancer service. Type is node port, change that to load balancer, and you don't need the node port. Alright, so if it's just a load balancer type, because I've got Metal LB installed and I'm gonna go with the type load balancer service, or I should actually show you because most of you guys won't have Metal LB installed. So let's go with the node port service, but it's the same if you want to use load balancer. So I would suggest you to use load balancer instead of node port, because we need to specify the base URL, and if you want to use node port you need to specify the worker node IP. But if your worker node crashes, then you won't be able to access your Spinnaker dashboard. So it's better to go with load balancer, but I will show you node port in this video. We'll also need a node port. Node port is 32323, and let's also edit the gate service, Spinnaker edit service spin gate, and change this to node port, and let's add the node port. The case is very important, so it's a camel case, lowercase n and uppercase p. Node port 32324. Let's choose the next port. Okay, kubectl -n spinnaker get service. Cool. So now we can see the deck and the gate service as type node port, and they are accessible from any of your worker nodes, worker 1 or worker 2. And the port is 32323 for the deck and 32324 for the gate API server. All right. So back in our Halyard container, we need to run these commands: hal config security UI edit. So UI is the deck service, spin deck service. We need to set the base URL. So -- override base URL, which is going to be http one of your worker node IP address. So I've got worker 1 and worker 2. The IP address for worker 1 is 172.42.42.101:32323, because this is the spin deck service. And let's do again for the gate service: hal config security, this time API edit -- override base URL is http 172.42.101:32324. So that's the spin gate service. All right, so now we are ready to hal deploy apply, and in here what I'm going to do is watch kubectl -n spinnaker get pods, and as I run hal deploy apply, you will see some of the pods getting created and the old pods will get terminated. So once all the pods are again running, then we should be able to access the Spinnaker dashboard. Let's wait for it and see what it's going to change in our cluster. All right, so as you can see here, there are new containers that are getting created because of the changes that we made. And so 0 of 1, 0 of 1. So for example, if you take the cloud driver, so once this new container is ready, the old container will be terminated. Similarly for the deck service, Echo, Front, Gate, Arca, Roscoe, for everything, once the new container, you can see the age here, 25 seconds. So that's the one that was recently started. So once they're all running, the old one will get terminated. As you can see here, the old deck service is getting terminated because the new deck service is ready. And I'll pause the video here and come back when they're all in the new version. Alright, so all the new versions of the pods are running fine. They're all in the ready status. So now we should be able to access our Spinnaker dashboard. So since we've set it to type node port, so we should be able to access it from any of our worker nodes IP address. Okay, so 172.42.42.101 colon 32323. So that's the port node port for the web UI service. Cool. So that's your Spinnaker dashboard. It looks very simple. It's a very simple plain dashboard. Applications, list of components that's already installed in our cluster, but don't worry about it. Don't worry about these. We will create new applications in the next video or so. And if I click this one here, you can see Spinnaker is version 1.16.5. Let's see how to upgrade it to 1.17.2. Applications, if you want, you can create an application and create projects and so on, which we'll be covering. If I've got some time, I will try and do some CI/CD videos around Spinnaker. But now let's try and upgrade this. So that is 1.16.5, and back in the Halyard container, if I do hal version list, the version is 1.17.2, so that's what we are going to upgrade to. Let's do hal config version edit minus version, set that to 1.17.2. So once that's done, you're going to run hal deploy apply, and that's going to change all these pods. All new versions of the pods will be deployed, and once they're all ready, the old version of the pods will be deleted. And while all these are happening, you can still use your Spinnaker dashboard. So that's the advantage of deploying in a Kubernetes cluster using Halyard. So if you used any other method of deploying Spinnaker in your Kubernetes cluster, and when it comes to upgrading your Spinnaker cluster, there will be some downtime. But if you used Halyard, like I've shown in this video, you'll have zero downtime. So at the moment, you can see the pods are getting upgraded. So new versions of the pods are being started, and the old versions are still running. So still you can interact with your Spinnaker dashboard, create application projects. So you can look at everything, and still we are in version 1.16.5. And let's refresh this page. Still you'll be able to access it, and we are on 1.16.5 while the upgrade is going on. And if you look at the spin deck, that's running, but that's the old version. The new version is also running. Yep, new version is running and the old version is being terminated. So now I think we should be able to look at the new version 1.16.5. if I refresh this page, Spinnaker, and there you go. So we are now on Spinnaker 1.17.2. So that's how easy it is to upgrade your Spinnaker with zero downtime. Alright, cool. So this will take again another 5 or 6 minutes for all the pods to be in the ready state, but that's Spinnaker dashboard. So that's how you install Spinnaker in your Kubernetes cluster, how to upgrade your Spinnaker. And if you want to delete everything, you can just do inside your hal container, you can do hal deploy clean. So that's going to delete everything, all the resources that it has deployed in your Kubernetes cluster. So this says this command cannot be undone. Do you want to continue? Yes. So that will delete all the containers that it has created in your Kubernetes cluster. So let's close this one. Deleting all service, deployments, secrets with labels. As you can see here, everything is being terminated. All right, so kubectl -n Spinnaker get service. Cool. So that's the Minio is the only service that we deployed. Everything else got terminated, and there are the last 3 pods to be terminated. kubectl -n Spinnaker get all. Yep, all of them have been terminated except these 3 pods. They are terminating. It will take a few more seconds. Yep, they're all getting terminated. So that's how you deploy, upgrade, and uninstall Spinnaker from your Kubernetes cluster. Hope you found this useful, and please follow this. If you've got any questions or any comments or any issues, let me know. I should be able to help you. The only thing to remember is your Kubernetes cluster needs to have at least 4 CPU and 8 gig of RAM, and you need to have dynamic volume provisioning. If you're on a managed Kubernetes cluster like EKS, AKS, GKE, then you don't have to worry about it. You can use their load balancer service. You can use their dynamic volume provisioning. But if you're on bare metal, you need to have dynamic NFS provisioning and metal LB for a proper production use case. All right. Thank you so much for your time watching this video. I will see you all in my next video. Bye bye.